Okay, let's continue the osdev here. This will be the start of hopefully better camera quality from now on. I'm using the Sony ZV-1 now, same as for my other videos, instead of the Logitech C920 webcam I was using. So be a little bit better quality here, a little different angle, but hopefully, that's good. But anyway, I wanted to start off by getting rid of int 10 and any remaining places that we need to. So the calculator we're going to change, so that doesn't really matter. The boot sector is fine for now. That's fine. We can keep int 10 in there, like only eventually. The kernel, we're only using it for a small graphics tester on a green square. The print string, the regular print string file, we aren't using anymore, so we can get rid of that. So let's do that. Let's do that. All right. Okay, the calculator we're not going to use anymore, so let's delete the lines or comment them out. So we're going to be changing the calculator in this this session. Let's just delete these lines for now. Move cursor, the lines are commented out, so we can probably get rid of those lines. Which we can right here. Alright, no more comments. Nope. Okay. So we have clear screen text mode, so we can change that to use our move cursor. So let's do that. Because the only files that we're using clear screen, I think, are the kernel and the editor. This is only, I think this is only being used in the kernel and the editor. And they include move cursor as an included file. So we should be able to move just by calling it. Doing that. So I should be able to make with that as well, but let's just check right quick. If we call clear screen text mode, but calling it in the editor and the kernel and, the file itself. That's okay. That's fine. Let's see if it runs. I think it will. That is not correct. Obviously. I didn't reset the stack, did I? Probably not. I did say it was late at night, right? Let's do this. Let's clean up the stack after. Not that that would be the issue. That's probably a big part of the issue. Yeah, you gotta make sure your stack's doing all right. So CLS should move it, and then stuff should now appear there. Again, we got scrolling working, so that's always good. Except after we delete, the line goes down and it did not scroll, but clear screen still works. Okay. Does it keep scrolling from that? All right. How about rename? It doesn't scroll on that either. For one line edits there after we press enter. But we can get rid of the commented lines in here now. So we're not going to be using these anymore. Alright, let's see. I guess we'll do delete file first. We're just moving the cursor down. Okay, we're just moving it down, that's why. I'll want to call probably print character text mode. So the character we want to print will be A and D for a new line. So we'll still simulate the new line here. So print character text mode. And then add 6. Well, it moves the screen data, so that's fine. I don't know if we're gonna have to move the character after. We're using it in here. We do move the cursor after, okay. So I'll just copy that stuff. Yeah, every time I do it, I move the cursor. Okay, that's fine. We'll put it a couple below here, okay, then we'll move it. Maybe I could add move cursor to the print character and string text mode functions. That would cut down on a lot of duplicate code for cursor every time I call them. I might think of doing that. I don't know if I'll do that right now. That is a good idea. I probably should do that, even though I'm not. So, okay, let's see if that works for deleting. This is only deleting, yeah. All right, so put down at the bottom of the screen, we'll delete calculator. There we go. Now it scrolls properly. So we'll do the same thing for rename. Is it rename file? Yes. Good, good. Cursor down for new line. I did delete right above here. Get rid of that code. Okay. I could also make a print new line, a little subroutine that does this instead of duplicating. That would be good too. I'll keep that in the back of my mind for future thing to start an episode with, since I like doing small stuff to start with. Get the brain running. Get rid of all this. Okay. Make and make earn. I don't know how to do that. No, you don't. Did not teach pottery to my OS yet, to my build system. Once my build system knows pottery, we'll be good to go. It can make all the earns we need. Okay, so yeah, delete works. Let's rename calculator, and there, now it goes down. Okay. And all the other stuff still prints. All right, cool. Okay, so other things are either starting on the calculator or changing the drive number to not hard code into 80. So what I can do is the same thing, just to make sure everywhere I have 80. That's where we're using the drive number pretty much, which is, yeah, the boot sector, the kernel, print file table, and file ops. That's not too bad. So there's not too much to change still. All right, but let's do that. Let's change to actually do a good implementation of the drive number, not hard coding 80. So yeah, DL. We'll move into drive number, drive num. I'll do the same thing. I'll basically do the same thing I did in the last, video for this, just it's correct. So I'm sorry for redoing all this. I know it's annoying to watch probably, and it's kind of pointless, but I don't know. I just want to do this. I don't like having hard-coded stuff. Eventually, I'll try to have variables or constants for all these, just numbers everywhere. We'll just do this for now. That's fine. Light drive num. Okay, so before we change the data segment, because I think that's what was wrong. When the data segment changes, we're not going to be able to use drive num in the same way if we set up a variable for it, of course. So drive num dp0, there we go. So the data segment ds right here, data segment, in real mode, I don't think in 32-bit protected mode, if you set up the segments all to be starting at 0 or 64-bit, oh, either one. But in real mode, since the segments can be different, point in different areas because of limitations, the data segment points to where your data is kind of offset from or located from. The assembler uses that. So our variables here in our files, in this example, drive num, here where this is defined, since a label is an address, which is just a number, that it has to, the assembler has to kind of reconcile that number somewhere. It has to originate somewhere, right? I know for this file in memory, we're going to load it for 7C00. That's kind of where stuff is offset from, but also it's going to use the data segment for, like hard-coded stuff here. Maybe also labels, like load kernel. But the data segment right here being 200, which will, since it's segment register in real mode, it's going to point to 200 times 16, which is 2000 hex. So location 2000 hex is where we're going to offset data from. So drive num, we could actually use it as, if we wanted to reference it, like, I believe we can do this and it would be valid to move stuff into here. Or I can be talking out my butt and this doesn't work. But anyway, I think you can also do this, offset from the data segment, since that's what this does implicitly, kind of, if you do this. It has to get that value from somewhere. So it's kind of the same as doing this. But I mean, when DS changes, the offset to this will change, right? The drive number will not be at the same area. So when this boots, this is probably going to be at 7C00 or maybe even 0. But when we change it up here before we jump to 200, if we try to use drive num as a variable after this point, it won't have a value. It'll probably be 0. Because the drive num that we would use up until this point, where we move 200 into data segment, is where it's kind of actually located. We assemble the file, it's going to assume that it's going to be offset from the initial DS in the file when we add assemble time, which is 200, which is 0. When we change it to 200, it's not 0, it's like way past. So we're not going to be able to access drive num. So that was kind of the reason I was failing last time. We need to change it beforehand, before we change it, and it should be okay. So we can put it on the stack or move it into a memory area or move it into DX or whatever. So right now I'm just going to go with DX. That's fine with me. We'll move it into DL. I know we just did it up here. I forget if int13 affects it, so I'm going to do this again regardless. So move it into there, drive num. So that way it is set before DS changes, so it should contain the right value and not 0. Then when we do jump, the far jump's not going to change the registers, so that'll be okay. So we'll go into the kernel. We can move it, I guess, just to start off. It'll be in DL. So we'll move into, I'll call it kernel drive num, just to differentiate it from the boot sector variable name. DL. Put it up here, kernel drive num. I do need to change command string to be, I'm just going to change it right now. Let's make it 255 or 256 bytes. I guess with the 0 to 255 be 256. We'll make it 5. I'm trying to think what 8-bit actually is, right? So 255 separate bytes, that's fine. DB0. I don't like that just being blank. That kind of annoys me. Kind of like there's no limit set, so I can overrun if I put in, 10,000 characters there, even though that would take a while to type. So anyway, kernel drive num. That was a digression. Sorry about that. Kernel drive num here, DB0. That should be all right. When we call things, we'll look for ADH here. Drive num, this will be drive num. It knows DL is a byte, so I should not have to put the word byte there. Shouldn't have to. And it's kernel drive num, not just drive num. That was the whole point of me renaming it. Like that. Alright, anywhere else? Right there. I need to save values better to be able to copy paste, but that's okay. Alright, not found anymore. So print file table. Here. So I want to use it before we call here. So let's do that. Move into DL. Alright, let's see right now if it builds without any errors. It does not. Undefined symbol. Invalid operand. Move byte. Oh, I'm not moving anything into there. Yeah. Yeah, that would make sense, wouldn't it? Move byte, move into there. DL. There we go. Alright, then it's undefined and what? In the kernel. I like how I don't notice these things, like right when I'm typing them. That's kind of, it's something to think about, right? How do I not notice these things when I'm typing them? My brain's working ahead of myself. Again? Really? Okay. Where else did I type it? Oh, right there. Where else did I type it? Nowhere? Okay, just 2 places. Invalid value. Oh, and it's over, really? It's over that again. Wow, that's good. Kernel's huge, man. Kernel's freaking huge as crap. Alright. 5120. 10 whole sectors, it's huge. That works, but now we gotta change the other stuff. because it is now A, which is 10 in hex, which means this starts at 12, which is C. That starts at D, and starts at E. Okay. And we may have to change the boot sector for that. Because file table starts at C now. Yep. Kernel starts at A. Okay. All right, we good? We're not good. Directory doesn't work. Because we didn't really change it here. Which is fine, which makes sense. Again, file table drive num, move DL. All right, here, this will be big long variable name, file table drive num. Anywhere else? Nope. Put it down here, put it below there. Big T is what we're using here actually. So we'll use the big T. T. Table drive num, and then this. That still does not work. Make that DH. Oh, starting sector to read is also C now, isn't it? Yeah, forgot about that. File table is at a different starting sector. That was probably the issue. Yeah, definitely was. Okay, but rename and delete won't work. So rename file down here before we call it. Let's move kernel drive num and DL. We'll copy the line. Delete file before we call it. Oh, I'm doing that already. Oh, look at that. I'm already doing it. Wow, I didn't think that would happen. We need to do it before we go to the editor as well. Yeah. So when we jump to it here, before we change DS, because that will make it invalid. So before we change DS, we need to, we'll save it off, move it into DL. Okay. Now let's mess with the editor. We don't need to do it first, but I'll do it here anyway. Before we change DX anywhere else. Move into, we'll call it editor drive num, sure. DL, save, passed in, drive number. Put it with the other editor stuff. Editor drive num, db0. Okay, so we call load file here, so let's move that into DL. Again, more overhead everywhere, unfortunately. Move it here before we call save file though. Figure it saved it, I guess not. Move DL. Keep forgetting. If I want to save the line, I can do YY, but I keep forgetting to do that. So then we should only have to change this file, where we call these things. And I'll just have an overall, like, file ops drive number, file drive number or something. Do I have any? I don't have a standard in this, right? Just called file. I'll just call it file drive number for now. Probably have to change it later. Bytes. So I'm gonna have to use that wherever we use 80H. Yeah. Let me put it in all the functions first. File drive number though. I want to name it num, right? Name it num instead. Rename and save. B 1 2 3. All right. At least I had the setup here. That was good. So instead of that, we don't need the word byte because it's DL. We'll move file, drive, num. Change it there. Where else? There, there. At least the changes are good because we used 80 everywhere now. We can just search for the hard-coded constant. Although again, global find replace is easier. But I like seeing exactly where it's at just to make sure. Okay. So let's assume that that all worked and then we'll run it and see if it didn't. That print reg is not relying on the drive number. Okay, so let's see if delete works. Delete did not delete calculator, so that's not good. Can we rename? We cannot, that's great. Can we load or save? Let's just find out. We can load. Yeah, that's one thing I forgot about. So delete file, what is the issue here? Kernel drive num into DL. Call delete file. Oh, the file table is going to be different, isn't it? Yeah, that's going to be C. Yeah, we'll have to look for 0BH as well. That needs to be C. Okay. That might have been the issue with delete and rename. But I'm going to change the editor when we jump back. Right before, oh, I had it. Jump 200, press enter first. Before we mess with DS down there. Editor, drive, num. All right, that builds, that's good. Let's check. And everything's good. Let's rename. Calculator to math. Let's rename, that's good. Now let's delete math because we hate it. We're not good at it. That works. So delete and rename are good. Let's run the editor. Let's try loading. That all loads, that's nice. Let's try making a new file, test. Ooh, it all goes in the first place. That's interesting. Is that because I changed clear screen? I think it is. I think it's still saving inside the file data though, so I'm just going to type out, test, and then I'll save here. Test file 01, return. So test file 01's there, so it did save it, so that's good. And then we can load. All right, so loading, saving, delete, and rename works. So I think the drive number is being passed correctly now. We can't believe I messed that up last time. Okay, we got this stuff working. So drive number is good. int10 is removed. I'm like real tired today, so I'm gonna probably end this here. Well, let me fix the editor thing first. Let me see if it works for binary. Actually, let me do that first. It may be broken for binary and other files. Yeah, it is. Okay. That's what I thought. That's keybinds. Yeah, text editor. We call print character. We move to the cursor. Update cursor position. Yeah, we're not doing that anymore. We got rid of that. So print character. Yeah, we don't need to do that anymore. We do need to move the cursor, but we don't need to do those where we're assuming it's updated because it's not updated anymore from BX and CX. We got rid of that. Changed it to use addressing instead. Click delete. Now I'm going to have to check wherever we're doing this stuff. Wherever we're calling print character text mode because we don't have to do that anymore. So let's just do that. It's text editor. Text mode. I want to go down one line. Okay. Should already be incremented, so I'm not going to. Alright, I might have messed up a lot more than I was trying to fix, so we'll see. That was all in the editor. Let's try to load the thing again. It still looks about the same. That types on the end. Let's try a binary file. The cursor doesn't move after I type. Alright. Create another file. Okay, this seems to work. The cursor does not move when writing binary files. That is in the hex editor portion. So after we print the character, let's move the cursor. Let's do that. Let's do that. We'll save it. And then we're not using that here either, so put it there. I think that was the issue, but we'll find out, of course. That moves it. Okay, cool. Does it change it at the end? I mean, we can put other numbers here too. It's valid hex. Puts it one extra at the start after the space. Because we shouldn't print the space if we're going down. We're moving x to 0 and then y is going down. I mean, we do automatically go down from print character, so that should be okay, I think. We probably don't even need to do this. I'm just going to get rid of it. Instead of going down there, we'll jump back to return from hex. That code's not even being called. Not even being called, so it doesn't matter. I don't need to move 0e into there. Oh, okay, because if it's the end of the line, yeah, I'm not thinking at all, dang. Yeah. Since we handle new lines inside the print functions, if it's the end of the line, we're moving 0 from the carriage return. So and that 0 would correspond to cursor x in the editor. So since it's 0, 0 will never be at end of line. So it's always printing the space. Instead of doing end of line, that's not going to work here, so we'll compare word. Why am I retyping stuff? Compare to 0. At start of line. If so, go on, else print a space. Start or beginning of line. Okay, yeah, that should be all we need to do. So let's check. We're good on our merry way here. We're at the end. Oh, one more byte. And then we start over. Okay. So that's not bad. We even got rid of a couple lines of code, I think, in the editor, but okay. So that's all right. We're good. Fix some printing issues. I guess I could fix the backspace in the kernel right here before I go. So when we press backspace, it moves left, but it doesn't put a space there, which is what it should do. So let's do that. All right, I want to print space. Print a space at cursor, because a backspace moves back and prints a space. That's kind of, it's in the name, right? So push a 20, which is a space in ASCII. Kernel cursor Y. Push word kernel cursor X. Call print character text mode. Add SP6. All right. I'll probably move variables and things at a later date to be at the top of the file instead of at the bottom. That kind of makes more sense in most other languages, but oh well. Right now I'm not. That's okay. We're having these over here, so let's call it constants. All right, and I'm not going to replace this right now, but I'll just have it here for the future. It'll kind of be a space or whatever. And it'll be 20H. ASCII space character. All right, then these are the regular variables or mutable data or whatever you want to call it. Still can't spell make, that's good. So blah, 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 blah. What happens? I'm pressing backspace, nothing happened. So that's not good. Well, this moves the cursor forward, doesn't it? So that means we move it back, but it moves it forward. So it's not moving at all? Maybe that's the issue. Didn't I say I should have done that to begin with or something? I probably did. In which case, I'm sorry. Make plenty of mistakes. All right. Sustain backspace. That's 1. No, it can only move back once. That's interesting. I don't know why that is. I don't know what the issue is. I know I move it back here. We don't need to move it initially. We need to move it back 1 space, print, which moves it forward 1 space, then we need to move it back again. That's 1 there. Okay, that looks to have fixed it. I don't exactly know why. I figured it would still be broken. I was just thinking we're at the end and we do, 1. We just don't want to move it on the second one. We have to move it back because when we print a space, print character text mode moves the cursor forward by 1. We have to move it back again. So the cursor position moves left. It prints a space, which moves the cursor forward, and then we move it back. So that gets rid of 1. Okay. Stuff should still work. Okay, well, okay, we fixed that. That's good. We can just do that. There we go. Okay, I mean, that seems to have worked. All right, so we're good. We fixed a little backspace bug too. Okay. So I'm tired. It's getting late here, very late. So I'm going to go sleep, get some good sleep, which I don't get enough of lately. So I will get to the calculator portion. I do have a calculator. I'll just put it here before I leave off. I have a test folder I use for programming stuff. Test, parse test. I think this is a recursive descent parser from stuff I've read on, Stack Overflow and other official authorities on the matter. I think it's a recursive descent parser, but anyway, I got a C file, test.c, and I got assembly files, which are, I didn't have to make 2 separate ones, but I did. Test and test2. ASM, which will be the calculator, and they work as I think a recursive descent parser, but a basic for function calculator with arbitrary nesting. So 2 times 3. The C one works with backspace, of course. The assembly one does not. I'm not handling backspace in that. So if I mistype, it's bad. But we'll do 1 plus 1 plus parenthesis 2 plus 1 parenthesis, like stuff like this. Well, not 0. We'll do minus 2. So 12. So let's see. 3 plus 6. And so is 9. 9 plus 1 is 10. 1 is 11. 3 is 14. Minus 2 is 12. So that looks to be right. And the assembly version is a little different, but it should give me the same answer if I can type it all up again. Minus 2. So I have it in hex. I might change this to print in decimal before I record it, but right now I'm printing in hex because I already had that as a solution from the osdev stuff. But C is 12 in hex, so that's correct. If you do something wrong, it'll say syntax error. It won't tell you where it's at. That could be for the future, but right now it gives you an error back. But it does not handle backspace, so if I put something bad and I go back, even though visually it goes back, it's going to give some weird number, right? Actually, it might still take it. 2 plus 89 is what, 91? What is 5 times 16 plus 11? I don't know. 4 times 16 is 64. So 5 would be 80 plus 11 would be 91. So that is correct. But if we put, garbage in, and I go back, try to fix it, it's going to say syntax error. Okay. Anyway, I guess open the C one. Okay, let's continue with the osdev, or, well, tonight it's going to be application dev instead. I'm going to actually implement the calculator. This is a basic recursive descent lexer parser, badly implemented. Like I said, this is a C file, but I have an assembly version as well that I'll be using as the actual calculator in the OS going forward for now. But this is a basic four function calculator: addition, subtraction, multiplication, division, and arbitrarily nested parentheses. So this is the sample, and also negative numbers, but this is the sample Backus-Naur form. If you know any sort of compiler theory, you've probably seen that. Maybe not really compiler, it's kind of basic interpreter for a calculator. So, but you could build off it for, any other general language, I guess. This is just the math part. Function declarations, it's pretty simple. We have, we're just following our BNF grammar here, Backus-Naur form. So I'm saying for this language, a valid statement could be one of these things. It's going to start with a sum. A sum is defined as a product, or a sum with the plus sign and a product, or a sum minus sign and a product. So a sum would be something plus, it could be two numbers added together or subtracted, or nested expressions therein. A product is a term, or a product multiply, or a product divided by a term. So multiplication and division. And then a term is defined as a negative term. To handle negative numbers, you have a unary minus in front, just the minus sign. Or a sum in between parentheses. So this handles recursive descent and arbitrary nesting. So you can have a number plus parenthesis, number plus number in parenthesis, and that'll work. Or, multiple parentheses within each other. It'll keep going down into other sums, which lead to other products, which lead to other terms, which eventually should terminate into numbers here. And then the semicolon is just saying it's the end of this line. So the semicolon is not valid in this language. I'm just ending the line with that. Okay, so we have, parse, sum, product, term, number. I have something to skip blanks. We have something to check if we have a valid digit or not. And a match if we're on a certain character, like the plus or the minus characters. We can call match with the plus character and see if it's valid or not, for example. Okay, then other global variables I have are just an 80 character buffer, which I'm not doing bounds checking on this, so it's not great, but just 80 characters, assuming the user inputs less than that. And a character that handles the current position within the buffer. Then an error. So you can make this like hash define error, but I just made it a constant to not deal with preprocessor more than I need to. So what are we actually doing? Well, we're getting a buffer. So whatever the user enters in from standard in, just, typed in up to 80 characters, they press enter or control D or whatever. It goes to here. We get the string. And we're setting scan to num to 0. So we're first checking if it goes into sum, right? If our number equals sum, so if parse sum, most of these parse underscore functions will return a number. So N32T. So sum, product, term, and number will eventually return a number or an error. If it's an error, we're going to print an error message down here. Otherwise, it prints a number. We're going to print it out at the end. So we have that. This is not the best way to write C. This is how I wrote it to be succinct, to be small. So if you have issue with it, I'm not a great C programmer. Sum is defined as, if it equals parse product. So that follows the Backus-Naur form. Let me just pull it up here. So our sum is defined as a product or sum plus a product. So the first one we're checking if the num we get in here is a product or an error. I put it in a loop so we can get multiple sums, numbers added or subtracted from each other. So if you have 1 plus 5 plus 7 minus 2 plus 3, it'll keep going. So we skip blanks in between. But after we get the first number here, if we're doing like 2 plus 5, after we get a 2 as the ultimate return value from this, we're checking if they're going to add or subtract. So if we match on an add, then we're going to get the next number and then add them together if that's true. Although if there's a minus, we're going to get the next number and subtract them. So pretty simple. Then we'll return the answer from that, the result. All right, so parse product is basically the same thing, except addition and subtraction. It is instead multiplication or division. So it's pretty much the same thing, except we're calling parse term instead of parse product. Parse term should be what ultimately gets the number. So we skip blanks to start off, and then we're matching on the left paren, the opening parentheses or right parentheses. So we're on term here. If we do not find a left parentheses, we're going to match for a unary minus. But anyway, this handles arbitrary nesting here. If there's a left paren, then we start over again and get the sum for whatever's inside the parentheses, which ultimately results in a number. Skip blanks, check for the end parentheses. If not, we keep going. And we have a subtraction in case we're doing a negated number, which this looks a little funky, but you can put a minus here and then parse term. I guess I could do this, but I think it makes more sense like this. Ultimately, we're going to return, calling this itself, but which should eventually return a number from this other edge case here. So if it's not a left parentheses and it's not a unary minus, then we're hoping we landed on a number. If not, we're going to send an error back. But how do we get a number? It's down here. Skip blanks is easy while matching on a space character. And match is, I'm not doing the best job of explaining, apologize, but this is just a quick run through hopefully. But match, we're just matching on the character. If our current character in the buffer that we're scanning for, so the current scan index position in the buffer is the character we're looking for, then we're good. We're going to increase the scan. So if we're looking for a plus in the character we're on after we consumed, like the previous number, or sum in this case, if it's a plus, then we're good. We're going to go to the next character. Otherwise, we'd keep reading the same one, and that wouldn't be very good. So, okay, the parse number, we're just checking if we got a digit. So I'm passing basically the number to here, passing a pointer to the number and address. Checking if it's, since we type it into standard in, it's all going to be character. Hopefully it's between 0 and 9. So we're checking here if it's greater than or equal to 0 or and less than or equal to 9. Because they're in linear order in ASCII, they're defined as that. So that's hex, 30, 39, then we're good. I'm going to take the current number, I'm going to multiply it by 10, and then add the character in the buffer that we're at. So if we have 22 minus 17, we get the first number that's a 2. At this point, number should be 0, so it'll be 0 times 10, which is 0. Then we're going to add that character in the buffer, which say, if it's 22 minus 17, it'd be a 2. And we're going to subtract the ASCII character 0 or hex 30, and that'll convert the ASCII character into an integer. So this will then equal 2. We're going to increase the scan pointer, or well, the buffer index, yeah, and then go back. But in our parse number, we have this in a loop. If we got the first thing and it's a digit, we're going to get the rest of the digits in the number. So we just put it in a loop here. So if it was 22 minus 17, the next 2 would go down here. This would be a 2. It would be multiplied by 10, which would be 20. And then we would add the other 2. It would be 22, and we'd return that. So pretty simple, pretty easy. And that is the whole program. So I know I didn't explain that very well, but it's pretty short. Hopefully it's mostly self-explanatory. I can run clang on it, and it'll work. And a.out. I believe I showed this at the end of the last part, but I'm just doing this again so we can have arbitrary nesting. It does work with backspace. My other version does not. I have 1002 minus 299. We'll multiply by, I don't want to multiply by too much. I'll do by 4 minus parentheses 23 divided by 4. And this is integer division. So it doesn't deal with remainder, it doesn't deal with floating point. It's all whole numbers, integer. So I'm assuming 2817 is correct. I don't know if it is, but I'm assuming that's right. I think it is. All right, so what is the other thing? Let's open up, well, I can look at tests first. So all I did is, for this test program, just, basic environment setup is here. Set in the video mode, reading in 2 sectors, because I set up the actual program in 2 sectors. So, and then we're jumping to it. That's all this is doing pretty much. Far jumping to execute it. Test 2. All right. Since this is defined as 1024, that's 2 sectors. That's why I'm loading 2 sectors. And then I'm concatenating this at the end. I'm using a make file to just use FASM on both and then concatenating both into a bin and then loading it into QEMU. That's all I'm doing here. So I tried to mostly translate this C program. It is a bit longer though. It's not 130, it's about 370, 380 lines. So a bit longer, but oh well. I do setup here at the top. I have a buffer. I'm setting up the stack from position 3000 hex in memory to 2000 hex by moving 200 into stack segment, since the linear address in real mode for a segment register is multiplied by 16. So 200h times 16 is 2000h in the stack segment. 3000 down to 2000 is 1000 in hex or 4096 bytes. So should be good for a good level of nesting if we need to. I don't have bool, but I can redefine true and false, and it mostly equals, the C way of doing things. I'm jumping over key loops so that we don't consider these variables. I could put the variables at the bottom of the file and not need this jump, but I just put them here at the top to make it read easier. And we have the scan position, we have the buffer. I'm printing stuff out as hex, not as integer. That is bad. Well, for readability, that's not as good. I didn't feel like adding a convert hex to int function or anything, so I haven't done that. I probably will, but I haven't done that now, and I might not do that for a while. So I left it as hex because I already had implementations for that from the previous development I've done in the operating system. Okay. And just a string for syntax error in case there was an error, and an error variable, which we initialized to 0. Okay. Because we can just check if error is true or false, which I could have done in the C one, but I didn't. So to get a line of input here, we can do fgetS. We can just do a nice clean one-line function call. But you can't really do that in assembly, or well, I didn't call the C functions from assembly. I did it all kind of from scratch, right? So, oh yeah, I got my hands are cold, so I got my homeless/hacker gloves on. They help a lot. So to get a line of input up to 80, I don't have a bounds check for 80. I could put that in, but I'm assuming, again, you're not typing up to 80. This keeps the example shorter. AH0, int16, that gets a keystroked. The character will be in AL, scan code will be in AH. Did they enter the enter key, which is 0D, which is the enter key, carriage return? If they did, we're going to parse what they entered. If they didn't enter the enter key, we're going to put it onto the screen with int10 here, and store it to the buffer. So once we got a full buffer, they press the enter key. We're going to start parsing here, which I guess goes, about to here before it calls sum. I guess we're at this thing here. So 0 to scan to start it off. We're going to call parse sum, similar to the C code. When eventually we return to print out the answer, that's what I'm doing here. I'm putting a new line before the answer, seeing if they got an error. If we did get an error, then we're going to print that out by moving error message into SI. Otherwise, we're going to print out whatever the answer was, which is getting into a hex string and printing out the ultimate hex string. So we're converting the number we got to hex and then printing it out. Okay. Print loop, we're printing. Are we at the 0? Are we at the end? If not, we're going to print it to screen. Okay. And then I'm initializing everything before the next line of input for the user by moving DI to the start of the buffer, XOR. So we're doing 80 repetitions of store string byte, which will store 80 into the buffer. Well, it'll store 0 into the buffer 80 times for 80 bytes and increment DI. So we're good there. Clears out the buffer, reset the false flag, error flag, and print another new line, then go get another line of input. So that's pretty simple for printing an answer and then going back. So parse sum. I'm using the C kind of calling convention here, pushing the base pointer, moving a stack pointer into the base, and then I'm subtracting 4 for local variable, 4 bytes for a 32-bit number here. 32. I'm not using 2 variables in the assembly example. I'm using AX for the ultimate number that's returned, and I'm using 1 temporary variable to hold an intermediate number, so a work variable. But AX I'm using to hold the number, so I don't really need 2 separate ones. But it's similar to the C one. We call parse product first. If we return an error, then we're returning an error. Else, we're going to, well, it's stored into AX, so we're going to store it into our local variable here on the stack, which holds our current working number. But I tried to follow the C example pretty explicitly. So we call skip blanks, which is similar. I'm calling match. I have a match function called match character, but I'm pushing the argument on the stack. So the character we want to match is a plus. If it's true, then we're good. If not, we're going to check if we got a minus for subtraction. Otherwise, we'll call parse product and get the other character that we're adding. After that ultimately returns, and it's not an error, we're going to add it to our number that we stored on the stack originally up here. And that does the sort of equivalent of num plus equal num2. We get the second number and add them together. If we got a minus, then we're going to get the number and, subtract them down here. Hopefully that makes sense. It's similar enough to the C example. Ultimately, when we return, I'm moving the argument off the stack into AX and returning. So I'm using AX as my return variable. For returning errors and all these, I'm just moving true to the error variable and then returning as normal. So we can check, if we got error, like right here. If it's true, then we return. We keep going back up the stack. But our normal returns for most of these are going to look like this, moving the base pointer back to the stack, popping the base pointer, and returning. So C calling convention type deal, but in real mode. Okay, parse product is pretty much similar to parse sum. It should be about the same, just again, we're checking for multiplication or division, and then multiplying or dividing. It's a little different. It's not as easy as the C example. I'm using imul for signed multiplication. If we just did mul, I think mul only takes one argument anyway. Mul is unsigned, but since we want to deal with negative numbers potentially, we're going to use imul for signed multiplication. And then I'm using bx to have an intermediate variable, since imul will need to be into a register destination ultimately, I think. Hold our original number, and then multiply it by our new number, and then move that back in to the stack where the original number was. So again, kind of the equivalent of multiplying them both together and putting it back. Division, we're doing integer division. We're not dealing with floating point, but you still get quotient and remainder. 10 divided by 2 is 5, but 10 divided by 3 would be 3, remainder 1. So we're getting the remainder and the quotient. We're doing sign division with iddiv, which can take one the operand. I'm using bx again for intermediate thing here. So our original number that we get for a second number that we want to divide by, which is the divisor, I guess is what that's called, right? So ultimately, when we get the second number that we're going to divide by, I'm moving that into bx. I'm moving the original number back into ax here. So bx num2, ax num1. I'm clearing the upper half of the dividend because an x86 division takes dx and ax if you're dividing by a word value. If you're dividing by a byte value, it would just use all of AX, but we're dividing by a word, BX here, 16-bit, so we're using DX and AX. So I'm XORing out DX so that we don't have any weird data in there to start off with, just clearing it for a clean slate. Divided by BX, and then for the answer, the quotient, so no remainder, the quotient will be in AX after the division, and the remainder will be in DX, but I'm not going to deal with the remainder. We're just doing whole number integer division, so we'll take our quotient, our final answer in AX, move it back into the stack here. Then when we return, we're going to move that back into AX anyway for a final, return code, whatever you want to call it. Okay, error's error, same return. So it's a little different, but it's still hopefully easy enough to understand. So hopefully this is a decent example of how to translate C into assembly. It's not perfect, it's not one-to-one, but hopefully it's a good sort of example of that. Can come in handy sometimes. And C does map pretty well to assembly, at least for x86. So, okay, so parse term, again, calling skip blanks to start off. So we're checking for the left paren. If that's true, we call parse sum again here for the recursion. So that's always good, calling parse sum in there. And then we're going to move that back into the local variable, which will move back into AX when we return. Skip blanks again, which is this right here. And then if not match, return error. That's what we're doing here. Pair AX, false, and then we'll go to an error. So I'm putting false into AX here to see if we matched on this or not. The return code in AX will be true or false as the result of match. I didn't explain that yet. That's why this is comparing AX to true or false. So if we didn't find a right paren, then we have an error. But after we call sum recursively, we get an answer that's good. We can go down. But anyway, if there wasn't a left paren, then like over here, else if match on this, we're going to check for a negative number. So I'm checking for a minus. If it's true, we're going to call parse term to get to the number. And then to make it a negative number, I store the original, I XOR AX, and I subtract the original number from 0. Okay, so yeah, subtracting our original number from 0 gives a negative number. So that's what I'm doing there. And then we're moving that back into the storage space and the local variable here on the stack. Okay. But if it's not a left parenthesis and it's not a negative number, we're going to check if we got a regular number here. So, which is what this is doing here in C, parse number. Okay, if it's true, we're good. We move it in. If it's not, we turn an error. Similar stuff here. Returning, move the number back for AX, otherwise get the error and return. So skip blanks is, again, it's a loop matching on the space here. So we're pushing hex 20, which in ASCII is a space. We could also push the word space. We could also do that, but that looked kind of weird, so I figure I would do 20. I don't know. I thought that looked a little weird in this situation, so I didn't put that, but it's equivalent. Then we're matching on that. If we found a space for a match, we're going to keep in the loop. As soon as we don't find a space, we're going to end the loop and return. So we're moving 0 into number like we did here. This is the only thing where I have a permanent variable. I don't use stack variables because we're zeroing it out every time. I didn't need to, make more stack stuff. I can save a little bit of memory here. We're pushing the address of it and we're seeing if it's a digit. If it's true, we're going to loop, push the address and keep getting, the next digits here. As soon as we don't get a digit, we're going to end the loop and return, or there's an error. This digit, we're setting up the stack because I'm getting an address variable, getting the address for the number we want to check. So I'm putting buffer into SI, I'm adding the word scan. So effectively it's buffer plus the scan position, which in C, that's, this syntax here, buffer array index scan, which is syntax sugar. I'm moving the data from SI into AL. We could do load string byte. I know I'm not doing that. But that's because I'm using a separate scan variable and I'm incrementing that later. If we were not doing that, then I could do load SB, load string byte, but I'm not doing that. So move the data from the buffer index by scan into AL. Again, see if it's between 0 and 9 character. If not, we return false. That's what this first line is doing. See if it's between 0 and 9. Okay, if it is, then I'm going to XOR CH and I'm going to store the buffer value, which is just 1 byte, into CL, just for another variable to use, another work storage location. I'm using CX. Okay, so our original number that we got, which is passed on the stack as an address, I'm moving that into BX. I'm moving the data at that address, which is our current number we're getting digits for, moving that into AX, and I'm multiplying by 10. So that does this, that's dereferenced num pointer multiplied by 10. That's what this part is. Okay, then the number that we got from the buffer position, so our buffer scan here, was stored into CL right here. So I'm subtracting the character 0 or hex 30 from that to convert it to an integer. And then I'm adding that value to AX, which is our number multiplied by 10. Okay, so that's what we're doing there. Same thing there. And then after, I'm going to reset BX to the address because we want to keep getting more digits for the same number in case there are more digits to get. And then we're going to move that back into the data at that address. So our number that we ultimately got is an AX. We want to store that back. So we're storing that to the data at the address of the number we passed in, which just kind of updates the value of the number. That's sort of the equals here where we're assigning it. That's sort of how that works. Okay, and then I'm incrementing scan. So the same thing as scan plus plus increment, moving AX to true. We did find a digit and then we return. So that as long as that returns true, we're going to keep looping here. All right. And the standard return, we used SI, so I'm popping it off to restore it. And we have a separate I to H, but our match function, again, is a little bit longer in the C version. It's okay. I'm using SI for the buffer, so we're pushing that again. Doing the same thing, move buffer, add the scan position to it, move that into AL. Move the character that we passed in. So if we matched on the space, this would move the space character, which is 20 hex, into BX. We move the original number, we move the buffer number, the buffer character into AL, and then we check whatever character we're matching for in BL. So we're comparing. So if there is 2 plus 2 in our buffer, and we're matching on the plus, the plus will be in AL, and the character, if we called match with a plus as an argument, or pushed it on the stack, it would be in BL. So, if they're equal, then we're looking for a plus, there is a plus, and we're good. If it's not a plus, we have an error, and we're going to return an error, or well, false, which will ultimately result in an error propagating. But if the character is true, we are looking for the right one, and it is found. I'm going to increment the scan position for the buffer, and then return true. So The only difference here, well, another difference, not the only one, is where we go out to print our final answer. So I kind of copied the hex stuff, the converting, the hex that I have in the osdev previously done. So, you know, it's stuff you've seen before. Just dx holds the ultimate answer, and we return it back. You can see previous videos if you want to know how that works in detail, or you could pause the video there and just look at it. So ultimately our answer is in hex string, we move it to SI. So if we have an answer, we're going to print it out. Okay. So I know that was very bad explaining, apologize for that. Or maybe it wasn't and I complained too much about myself, which is probably also true, but hopefully that's a decent explanation of, you know, converting a basic, badly implemented, converting a basic lexer parser for some sort of recursive descent interpreter for a calculator. But that does work. We have that make file that I showed earlier, which ultimately results in here. We can do something similar 10 times. This does not work with backspace. So if I mess up and try to enter something, it'll say syntax error. But 10 times for, let's do +3. So 10 times 7 is 70, although it's returned in hex. So let's see, 4 times 16 is 64, plus 6 is 70, so that's correct. But if we put in like garbage, it'll say syntax error. It won't say where the error is. That might be a good improvement to put in eventually. Say, hey, this character's wrong, you dummy, but I'm not doing that yet. But this works similar to the C one. This does work with negative numbers. It works with 0. So if I put in -3, so this is the 2's, I believe it's, 2's complement version of negative numbers. So a -1 is counted as basically the max value that you can have, which is FFFF. It's technically -1. So a -3 is FFFF minus, 3. So it would be E and then D, right? Because if you add 3 to that, then you get 0. That is correct. Hopefully you can see and believe me. So what I'm going to do with that is kind of put that code or similar code to it into our calculator and try to get it to work. And if that works, then I'm good. And that's all I'm going to do tonight. So let's kind of move it into there, right? All right. So this stuff. So that is test2, right? .asm. Calculator currently does nothing. We do want print string, but we're not going to do print message. Not going to do this stuff. When we move back, we will do this to jump back to the kernel. I guess I'll call this like return or something. Return to caller. Well, this returns to the kernel right now, so we'll call it return to kernel. Sorry, the kernel passes the drive number here, so that's the first thing it does. So we're going to have to pass that back. Maybe I want a better implementation where we don't have to pass that around if we don't need to, but again, right now I'm not doing that, so. This is padding at the end. I don't know if this needs to be 2 sectors, but my example is 2 sectors, so I'm going to make it that way for now. Yeah, before we change DS, we need to move into DL, whatever the drive number is. I did already do this. Before we jump, yeah, we're storing the drive number to use. Okay, so that's already being there. I'm going to do like the other one called setup, or well, I'll do calc setup then, because setup is a reserved word. Yeah, I'll move it off. Move it off here. Calc drive number DL. I can put variables up here, I guess. That's fine. Do similar stuff here. This and variables. I think, never mind. I'm yanking. I thought there was a different key to copy, but I'm just gonna yank because I don't know what copying is. In Vim, I just know yanking, which should be same as copying, but I think it's a bit different. Anyway, so we'll jump to key loop. The stack is already set up. We don't have to worry about that, but I will move di to the buffer. I'm going to change to where we use our, our previously worked on print character text mode or print string text mode functions. But for getting it to work right off the bat, I'm just going to use int10 still so that I don't have to debug too much at once. We do have to decide when to end and jump back to the kernel. That is not in here. This is just permanent, looping around. So I could put something else. Here, instead of enter, we'll do, or well, we'll keep enter, but we'll compare against something else. Compare to escape, maybe? I don't remember what escape is. Is it 10? Let me look. I always forget. Okay, so escape looks to be 1B in hex, or 33 in decimal. So we'll try, well, sorry, 27 in decimal. So 1B should be the escape key. I think that's the escape key. 1B hex escape key. Just to get something a little bit different. And we'll return to the kernel. Okay. Otherwise, we're going to store it to the buffer and we'll print it to screen. All right. So we'll just copy this. I don't know if I want to copy it one function at a time. I don't think it matters though. We'll do the whole thing. Yeah, I guess I do need to copy the I to H unless I include it. I might be able to call print hex instead of doing this conversion, but I'll keep it there to start off. Again, we'll see if this works or not. I'm not sure if I have to change anything else. I think this should hopefully work as is. Let's see, I guess, if it works. This is going to be 2 sectors, so we will have to change that in the file table. But that is the only thing. File size is 2, and I can't type 2. There we go. So instead of E, this will be F. Ooh. Changes once again. Okay, no file or directory. So move. Oh yeah, we didn't put that actually in, did we? Nope. We didn't actually make that a variable. Calc drive number is a byte. There we go. Okay, that worked, which is all right. So here we go. Calculator. I don't like that. I'm going to rename it to calc. All right, that is there. So let's call calc. So I'm not clearing the screen or moving the cursor. But let's see if this works like start off. We'll just put in a 1. Okay, it did move it to the top of the screen, so that's interesting. If we put in a 1, we get a hex 1. If we put in a 10, I get nothing. So looked like it failed there, but that's okay. It did put in a 1 to start off. So before we do anything, let's clear the screen, right? Let's do that. Point to the start. Let's move that off first. Or I could clear the screen in the kernel before I call a program. Maybe. If it's going to be cleared anyway, that way I wouldn't have to put it in called programs. But I don't know. I might do that. We can put it here first though. We'll just do this for now. Which I say all the time. We'll clear the screen first. I think it's clear screen text mode. All right. Let's do, I could put include files at the top as well, I guess. Constants, variables. I guess I could put it here. Include files. Can't spell. So this is in, is it in screen? Man, I really should know these things. If we call that, that'll call move cursor, so we'll have to include move cursor as well, which is okay. Clear the screen first, move the cursor to the top, and then we'll see what happens. So let's just see. All right, that does clear. So put in a 10, it printed stuff over there, which is weird. I don't want that. And nothing printed out there. We can type some more. That gives syntax errors as well. So the buffer's messed up. So when we're printing and going back, the buffer's getting messed up. Because we're printing to ESDI, and we're changing DI to point to the buffer. Yes, so we will have to use our print character text mode or print string text mode functions. That's all right. I knew there'd be some issues here. This is how you port software, by the way. This is a very small example of that. Porting my own software to my own OS. But yeah, this is kind of, you deal with errors that come up. Everything I deal with has errors, and everything I do has errors, so gotta deal with the errors that come up. But that's okay. Okay, where do we print? Here, we store it to the buffer, so let's include the files then. Let's include the files. This will be print, and it'll be print. We'll do print character, text mode. All right. Print character to screen. Do that. Otherwise, print character. Which means I need the cursor position. So I need cursor position variables in here. All right. Calc cursor X. Which, those are words, aren't they? Yeah, because we're going to push them, so we'll make them words. And we'll do Y. We'll start them off at 0. Push word, calc, cursor X. But we push Y first. Call print character text mode at SP6. Okay. Alright, so let's see if, you know what I could do? I learned Vim, runs commands with exclamation mark. I haven't been doing that because I just kind of learned that. So let's see how that works. We run make. Okay, that did work. So if I run make run, so I don't have to leave Vim to compile, or well, to assemble and run the thing. I can do this, and then when we press enter from the output screen, it should go back. We'll see how that works, but anyway. See if we can just type in characters. We can, although it prints in a weird position over there. But we can print, and it's syntax error, and we keep printing. Okay, and it goes back. All right. That way I don't have to go back and forth to the shell anymore. I can just run it in Vim. So what is the issue there? Let's see if the escape key works. Because that's something. I didn't need to go all the way back. Oh well. Let's see if escape goes back, so we're good there. That's good. But it prints garbage. That should not print a green block there. Okay, I found my issue. It is with clear screen text mode. It is because I never changed it to change this. I'm using push and pop A in here. Push and pop A only affect registers AX, BX, CX, DX. I think stack and base. I have it in here. So the 16-bit version and FASM, the assembler I'm using for push A, saves AX, CX, DX, BX, value of SP before AX was pushed, base pointer, SI, and DI. It does not affect the segment registers at all. Since it's changed up here, ES is changed. It's not restored at the end. So changing it in here made it work a little bit. So I'm going to change it in clear screen text mode though. I'm just going to additionally push ES. Well, we can just push everything we're affecting in here really. Let's change it to do that. Let's make this better. We'll push ES. AX, I guess, although we usually use that for return codes. That doesn't matter. We're using DI in this file. We're using CX in this file. And that is it, right? Yes, other than move cursor, which handles stuff on its own. But let's do these four. And let's just change this. Hopefully this doesn't mess anything else up. We'll see if it does. Pop AX, pop ES. Okay. So that way I shouldn't need those things there. So let's see. It shouldn't change anything. Should be able to go down here in the kernel, do clear screen, go down. Okay. So directory So calculator, we put a 1, it's a 1. All right. So the cursor doesn't move after we print a character because I didn't put that in yet. But a 1 is a 1. And the cursor also will not move down. It'll print where it originally was because we're not saving it in the variables in the program yet. A 10 is a 10. If we do something like 10 minus 2, should be 8. Okay, we're good so far. Let's do 4 times 3, it should be 12. Okay. So we're good right now. Escape escapes. The only issue with the escape key is with my keyboard and OpenBSD right now, escape works as caps lock. So it's very annoying. That can lead to bad behavior in like Vim and stuff. So I'm going to change that probably off recording, but I got to keep that in mind. For some reason my escape is caps lock because I rebound it. So we should just need to mess right now with cursor movement right now. So we print the character. Let's move the cursor after. Which will be just the values, right? I believe, yeah. Calc cursor Y and calc cursor X. And move cursor and add SP4. Okay, and that is up here. Yeah, I have move cursor included. So again, I don't need to escape to do that because I know how to run commands in Vim, but that's not muscle memory yet, fortunately. So the cursor should now move forward. Okay. And I'll put up there. All right. Okay, so we need to make it work for the new lines now to go down correctly. The cursor, that is. Printing a new line. So let's just move AX 000A. Yeah, push word, calc cursor Y, then we push X. And we do this other boilerplate, you know how it goes. Push character, or push the address and then jump to print character text mode, otherwise known as calling. Print character text mode, good save, self. Off the top of my head, talking too much. All right. And we do it all again. I think I saw something. Shift V, I think, is by line. Okay, so we can just copy lines, do a Y, and then paste again. Ah, nice. I'm learning my editor more, guys. I promise we're good. Okay. Let's change where we print out the answer here instead of doing this. We could call print string text mode, which is what we're doing here, right? Instead of this print loop. So let's do that. Let's add it here. We'll do string. Calc cursor Y. Change that to X. Call print string text mode. Add 6. Okay. Okay, this moves SI to error message and then goes to print loop. So I guess we'll jump to clear buffer instead. We do that instead, but we do this same thing. So again, copying, not great. But that's all right. It's just stuff to improve later. Print error message, else print num as hex. Okay. And then we gotta change the new line again. Really should get a better way of doing it than doing this stuff. Don't do that. Shift V. Yeah. Right. right. Don't do this stuff. Okay, and then we go next line of input. All right, so let's see what that does. It does not work. Oh, it is more than 2 sectors. Beautiful. Well, that's always nice. R3, R6. I was hoping it would be less, but it's not. It is 2. Okay. Or it is 3 rather. So this is 3. Oh, editor's at 10 now. That's nice. So let's change that to say 3 sectors. Well, we'll just say. We'll say pad out the rest with zeros. All right, that seems to work. Calculator, so let's put a 10, press enter. It does not go down. That's not good. And it prints a 0, which is also not good. It should print a 10. Print 0 for all of them. Well, syntax error for that. Okay, well that's good. Oh, we're not pushing AX, duh. You gotta do that, you big dork. All right. Otherwise it doesn't know what character you're trying to do. It had garbage for there, that's why there's just a blank. Copy the line, there we go. And then put one there. Simple mistakes. Now it goes down, but it prints 0. So I have issues with printing the hex number, okay. Which I figure there would be. That is I to H. So we're calling that moving X string to SI. So it should be an AX at that point. We're not resetting AX, so that's probably the issue. When we do the start parse and all. Yeah, that's why I pushed it to begin with. Yep. Okay. Let's do it one more. Well, actually, we can use memory, it's fine. Let's push it. Let's make a result variable. Let's do that. And before we go to print, we'll do it here, move into AX, result. Okay, and SI, so let's see if that works. I don't think I saved. Need to save it first. Otherwise, when we make it, won't get the latest changes. Okay, 10 is 10. 4 is 4. 2, 3, 30 minus 1 should be 29. Which would be 16 plus 13, so that's correct. Let's do something fancy. What if we start off with parentheses, just to make sure it works? Oh, that's 3, that's good. Okay. Three plus 1. 1 plus 2 is 3, 5, 7, 8, 9. So that's correct. Okay. So now we can write Lisp. Okay. With all the parentheses and bad joke. Okay. Anyway. So we got that working. That's good. So I to H. This is like a subroutine. I could call print hex instead of doing this, since we have print hex. So let's try to make it work with that, actually. That's the whole reason I made print hex, was so we didn't have to do that everywhere. Let's do that, actually. So when we go to print it, result to AX, we'll move it to DX instead. And we'll push word calc cursor, push in the address, yeah. Calc cursor Y. And X, I'll print hex, and add 4. That way we don't have to do that. That should be all right. So we don't need I to H anymore. Get rid of that. Make the file a bit shorter, 418 lines. Still kind of long, that's all right. Don't need hex string. All right, so let's see if that works. Make and make run. That did. Hey, there we go. 343 plus 4. I don't think this is going to work. Plus 2. Maybe that's correct, maybe it's not. I don't really care. We're good here. 1 plus 1 is 2. All right, so last thing, let's make a little other subroutine. Now I'll just put it down here. Call it print new line. Call it print new line. This will do this stuff. Print the A, move the cursor, print the D, move the cursor. It's all it's gonna do. All it's gonna do. And then return. All right, we do that here. So let's call print new line. So let's see if that works. And then I'll probably call it. Hey, look, it works. Awesome. I like when stuff works when I don't expect it to. Why would I not expect it to? I don't know. So 10 plus 2 plus 16 will be 28. So let's try to do 56. Is that what that is? 12 plus 16 should be 28. 12. It's 44. So I don't think that's right. 44. So it looks like I have some issues there. That's not the right answer. Dang it. Well, it mostly works. I might do some debugging in my off time. I'm tired. It's been a long day. It's late at night and I need to get some sleep. So I'm going to do that. The calculator mostly works though. Interrupt 16H, where we get the keystroke. I'm going to try to replace that with polling the keyboard data port instead, which I do have an example of. Yes, I have it over here in keyboard test. So yes, I will. I'll show that example and how it works, and then I'll try to put it in to the OS, kind of like I did with this calculator thing. I'll show it, explain it, and then try to put it in. And I'll try to go and replace int 16. Hopefully it goes a little bit smoother than replacing int 10 with the printing, but knowing me, it probably won't. So we'll see how that works. Replace interrupt 16 with keyboard polling, not with interrupts. When I move to 32-bit, which is after replacing all these int keywords, when I move to 32-bit, I will then probably make an interrupt descriptor table with at least one entry for the keyboard, and then maybe, you know, change and refactor so that it works with that, with actual interrupts, because that would be better than polling the data port. For now, I'm just going to try to go with polling the data port to get keyboard keystrokes in the form of scan codes that will have to make a lookup table kind of to translate to ASCII characters and then go and print them out or put them where they're supposed to go. So, and then after that, I'll try to replace int 13 with ATA data ports. I'm not sure how resetting the disk will go, but I'll do some research on that. But yeah, after we replace those, then I'll probably move to 32-bit and then VESA BIOS extensions, get a better graphics mode, and then refactor everything like printing. That'll break from that, and then we'll go on from there. So yeah, I do hope you enjoyed watching. If you didn't, that's okay too. I can have a boring monotone voice. I'm trying to put more inflection into it, but it's hard for me because I'm not the most expressive person. But yeah, hope you enjoyed, really do. And I do really appreciate all of you watching. I recently passed 500 subscribers. I know I haven't done anything special for that. I don't know if I need to. I might make another like a snake game demo, but that won't really be a special video. It'll just be a video. So I don't know. If you have any ideas about what you want for that, then let me know. If not, I might just celebrate with like a drink or something on my own time. But I do appreciate all you wonderful people. I really do. Thank you for watching. I've rambled on enough. I'll let you go. Yeah, I'll see you on the next one.